You may want to have high-speed internet for doing Linux OS software updates. You will also want to have 15 to 20 gigabytes of free hard drive space for the Linux virtual machines. You can also use any CentOS 7 server with GUI installation. This means choosing server with GUI on the software selection screen. You will also want to make sure the first user is an administrator. Using Apache and Basic Auth, we create a private, password-protected website. We then expand this configuration to include access control for group collaboration. Then we move on to creating virtual hosts running on standard and non-standard ports. Utilizing a TLS private key, we create a secure name-based virtual host. Also, we use Nginx to create its version of virtual hosts. VirtualBox guest editions are pieces of software installed in the guest operating system that gives the guest OS a direct communication path to VirtualBox. This allows the guest to take advantage of faster drivers, better screen resolutions, and better integration between the guest and the host. I highly recommend installing guest editions as it makes the virtual experience smoother. When running a VM, you may notice if you press Host plus F to go into full screen mode, that CentOS doesn't fill the entire screen. Installing guest editions will fix this, among other things. There are a few prerequisites for installing VirtualBox guest editions. All CentOS system updates have to be done and the VM has to be rebooted to ensure CentOS is using the latest kernel. Also, the network needs to be functional. To update the system software, open a terminal in your VM by selecting Applications, Favorites, and Terminal. I'm going to make mine full screen. I'm going to bump my font size. Now type in sudo space yum space -y space update and hit enter. And then type in your password. There's a chance that the yum database may be currently locked. If so, you need to kill the other yum process, which is listed in the error output. In this case, you'd type in sudo space kill space -9 and the process ID listed in the error output, and then you'd run the yum update command again. In my case, the update is going well, and I only have one packaged update, which is the kernel. When the updates are done, reboot by typing in sudo space reboot and hit enter. Type in your password. Once the VM has rebooted, log back in and open a terminal. Now let's install the Development Tools software group by typing in sudo space yum space group space install space -y space -- set opt equals group _ command equals objects space double quote development tools double quote and hit enter. Type in your password and hit enter again. Due to a change in the way software groups are handled in CentOS 7, we need to add the -- setup option listed above. In your case, it may work without it. We need the double quote so Yum knows we're installing one software group called Development Tools. When that's done, we'll need to install the kernel source. Type in sudo space yum space install space -y space kernel -devel and hit enter. After Yum has finished installing the kernel source, we can close the terminal window. Now let's go to the virtual machine menus. If you're in full screen mode like I am, then you'll need to press the host key to release your mouse pointer and then hover it over the bottom of the screen. The menu bar should show up. If you're not in full screen mode, you'll need to press your host key and then click on the menu at the top of the window. Select Devices and insert Guest Edition CD image. Once the dialog pops up, click on Run and type in your password. Once we've authenticated, it will start installing guest editions. The installer is taking the development tool software and is compiling a module for the Linux kernel and then installing it, which should finish in a few moments. Now that the guest edition software is installed, reboot your VM again by going to the top right-hand menu and selecting the power button, and then click Restart. Once it has rebooted, log in and you should be able to go into actual full screen mode by pressing Host key plus F. If your VM rebooted OK and your guest editions installed successfully, you'll want to create a new snapshot. With our VM running, press Host plus T to create a new snapshot. We'll call this snapshot Guest Editions and hit Enter. You will want to follow the same procedure for each of your virtual machines. To configure your VM settings, click on RHOST1 in the VirtualBox Manager window and click on Start. Go to full screen mode by pressing the host key plus F. The host key is listed in the bottom right-hand corner of the window. In my case, it's the right control key. Full screen mode will make navigating the desktop much easier. Once your VM has booted, log in when prompted. On the desktop, click on the top right-hand menu. Click on Wired, and then click on Wired Settings. Click the slider gadget to turn the network on, and note the IP address. In my case, it's 192.168.1.86. Then click the Settings gear in the bottom right-hand corner. Click on Identity in the left-hand pane, and then click on Connect Automatically. Now click on Apply. You can close the window now. Let's also set the host name for our new VM. Click on Applications, Favorites, and Terminal. I'm going to make mine full screen, and then run the hostnamectl command. Type in sudo space hostnamectl space set-hostname space rhost1.localnet.com and hit Enter. Type in your password when prompted. For better shutdown support, let's also run the ACPID service. First, we need to install it. Type in sudo space yum space install space -y space ACPID and hit Enter. Once it's installed, type in clear and then let's enable it. Type in sudo space systemctl space enable space ACPID and hit Enter. We'll also want to start it, so bring your line back and change enable to start. It should read sudo space systemctl space start space ACPID and hit Enter. Now press your host key plus F to go out of full screen mode. And press your host key again to release your mouse pointer. And we'll flip back over to the VirtualBox Manager window, and we'll start up RHOST2 so we can configure it. Click on Start. Press your host key plus F again to go into full screen mode. Log in when prompted, and then on the desktop, go to the top right-hand menu. Click on Wired, and click on Wired Settings. Click the slider gadget to turn the networking on, and note your IP address. Mine is 192.168.1.87. Now click on the gear icon in the bottom right-hand corner, and then in the left-hand pane, click on Identity, and click the Connect Automatically checkbox. Click Apply, and then close the window. We'll also set the host name for a new VM. Click on Applications, click on Favorites, click on Terminal. I'll make mine full screen, and I'll run the hostnamectl command. Type in sudo space hostnamectl space set-hostname space rhost2.localnet.com and hit Enter. Type in your password when prompted. For better shutdown support, we'll also run the ACPID service, which we need to install. Type in sudo space yum space install space -y space ACPID and hit Enter. Now type in clear and we'll enable the service. Type in sudo space systemctl space enable space ACPID and hit Enter. Now let's bring your line back, and we'll start the service by changing enable to start. The line should read sudo space systemctl space start space ACPID. Now let's also add local name resolution to our etc host file. We'll need both the IP address of RHOST1 and RHOST2. Type in sudo space vi space /etc/hosts and hit Enter. I'm going to go into insert mode by pressing the I key, and then we'll go to the end of the file and add a line. Now type in the IP address of RHOST1. In my case, it's 192.168.1.86. Space rhost1.localnet.com. Space rhost1. Now hit Enter and type in the IP address of RHOST2. In my case, it's 192.168.1.87. You'll want to type in your IP address of your RHOST2 here. Space rhost2.localnet.com space rhost2. Save and exit by pressing Escape, X, ! And hitting Enter. Now let's test connectivity by pinging RHOST1 by name. Type in ping space RHOST1 and hit Enter. After it sends a couple of ping packets, press Ctrl-C to cancel. If it successfully pings RHOST1, you can continue with this course. If not, go over the steps in this video until you get it to work. Do not proceed on until the step works, otherwise the rest of the course cannot be completed. Now let's copy this file to rhost1 so we have local name resolution on both machines. Type in clear and then type in sudo space scp space /etc/hosts space rhost1 :/etc/hosts and hit enter. Type in yes and then type in rhost1's root password. Once this is done, close the terminal window and create a snapshot by pressing your host key plus the letter T. Name the snapshot Network Configured and click on OK. Now you can shut down rhost2 by going out of full screen mode by pressing your host key and the letter F. Now click the close gadget and make sure Restore Current Snapshot is selected. Now go back to your rhost1 VM and create a snapshot by pressing your host key plus the letter T. Name the snapshot Network Configured and click on OK. Power the VM down by pressing the close gadget. Select Power Off the machine and make sure Restore Current Snapshot Network Configured is selected and click on OK. We now have two VMs named rhost1 and rhost2 with host names configured as well as network settings. Both VMs have local name resolution configured so they can reach each other by name. For this course, we'll be installing CentOS 7 Enterprise Linux. To install from full DVD, we need to download an ISO image from the CentOS website. We'll do this by opening a web browser and browsing to the CentOS download site at centos.org/download. Click DVD ISO and choose a server near you. And click on Save File and click OK. If you don't know where any of these servers are, just randomly select one. Now that our CentOS 7 ISO image is downloaded, we can install it. To install CentOS 7 in a virtual machine, we need to have VirtualBox running and then click on New. Let's name the virtual machine CentOS 7 Full DVD. Then click on Next. Now we'll set the memory to 1.5 gigabytes or more if you have it. Keep in mind we'll be running two virtual machines simultaneously in this course, so you want to use less than half the available RAM for each. In my case, the dialog box shows I have 16 gigabytes of free RAM, so I could give each VM up to 8 gigabytes if I wanted to, but that's not necessary. I'm going to set my RAM to 1.5 gigabytes and click Next. The next dialog is for the virtual disk. Click Create. Then click on Next to accept the virtual disk type and click Next again to accept Dynamically Allocated. This saves space by not allocating all of the disk space up front. We can now choose the size of the disk. The default is 8 gigabytes. There's nothing wrong with selecting a larger size than the default if you have the extra space available, but you can always add a second VirtualBox drive later if you need it, so it's okay to just take the defaults here. Click on Create. Now select the VM named CentOS 7 Full DVD and click on Start. Click the folder icon to select the CentOS 7 ISO image. And then click on Open. And then click on Start. On the boot screen, highlight Install CentOS 7 with the cursor keys and press Enter. You could choose a second option to test the install media as well. This is mainly for ISO images that have been burned to physical disk. This will test to see if the disk is not corrupt. We don't usually have to do this for ISO images that reside on the hard drive. To make installing easier, go to full screen mode by pressing Host key plus F. In my case, the host key is the right control key, which I can see in the bottom right hand corner of my VM window. As such, I will press Right Control F. In the first dialog, choose the install language. This is just the language used during the installation. And click on Continue. We now see the installation summary screen where we'll configure how our OS is installed. Click on the date and time and choose your time zone and then click on Done. Next, we'll click on Software Selection. These are installation configurations which go from a very bare install without a GUI to full-fledged desktop workstations. The default is minimal install. We're going to choose Server with GUI. This configuration doesn't include a ton of packages, but still has a full graphical interface. Don't get too worried about installing software here, as it can all be done later. Now click on Done. The next thing we'll do is click on Installation Destination. Make sure the ATA VBox hard disk is selected. If you choose Automatically Configure Partitions, the installer sets up 3 partitions automatically. There's nothing wrong with this choice, as the default partition layout is pretty good. If you choose I will configure partitions, you can set up partitions manually. Using this option, you still have a link for the installer to create the partitions for you. The advantage to choosing I will configure partitions is that you get to see the default partition layout and modify those results if you wish. Let's click I will configure partitions now. You may also notice that at the bottom of the screen, there's a checkbox labeled Encrypt My Data. If you're installing on a mobile device such as a laptop, I recommend turning encryption on. By default, CentOS 7 uses the AES algorithm to encrypt. If you have a recent Intel CPU with AES-NI instructions built in, there will be very little performance degradation when turning on disk encryption. For this course, we'll leave it turned off. Now click on Done. This brings us to the manual partitioning screen. Click on the link titled Click Here to create them automatically. Clicking this link brings up a new screen showing the proposed partition layout. The installer wants to create a small partition accessible as /boot, where our Linux kernel and other boot files are stored using the XFS file system. Second, it wants to create a much larger root partition where the rest of the OS is stored, also using the XFS file system. It also wants to create a smaller swap partition used for virtual memory. We can add any of these configuration details on the screen. Let's just click Done and accept changes to accept the installer's suggestions. We don't need the network configured to install with a full DVD, but if you wanted to configure the network now, you could. We'll do it later. Click on Begin Installation. While the install proceeds, we'll give the root user a password and set up an admin user. Click on Root Password. You want a very strong password here for the root user because in Linux the root user is all-powerful and the username is known to hackers, making it a target. If a hacker were to get this password, they'd have access to the entire system. The installer tells you if your password strength is good or not. Use a combination of numbers, letters that are both uppercase and lowercase, and symbols for your strong password. The installer will let you proceed with a weak password if you wish by clicking Done twice, however, it's not recommended. Now let's click on Done. If the installer doesn't let you go on, then the two passwords probably don't match. It doesn't give you a lot of indication of this, but if you look at the bottom of the screen, you'll see the message. You don't ever want to log in as root, and especially not on the GUI. The root user has too much power, and there are too few safeguards. So on Linux, we create a regular user. Click on User Creation. Here is where we'd enter our name into the full name box, and it will create a lowercase version of it for our username. Let's use the name User1 for this course. You can always add a user with your name later if you wish. We'll also set our password on the screen. We'll create a strong password here as well because we're going to make this first user an administrator by clicking on the checkbox labeled Make this user an administrator. It's very important that you click this box now as the rest of our course depends on it. If you fail to click this box, you'll need to log in as root after the install is finished and add this user manually to the wheel group. It's best to do it now. We'll also want to give this user a strong password since we're giving them admin privileges. And then click on Done. The install will take between 20 minutes to an hour depending on your host computer's hardware. As soon as the install is finished, you will be able to click on Reboot to reboot into your new CentOS 7 VM. As soon as the system reboots, we'll want to click on License Information, click on I accept the license agreement, and click on Done. And then click on Finish Configuration. Now log in as the user you created. Notice that root isn't even given as an option in the GUI. You can specify any user if you click on the Not Listed link. However, I really don't recommend logging in as root. As soon as you log in, you'll be prompted to choose your language. I'll choose a default which CentOS gets from the installer and click on Next. I will also choose a default for the keyboard. Click on Next again and click on Skip Creating Online Accounts, then click on Start using CentOS Linux. As soon as we're logged in, CentOS displays a Getting Started window explaining how the CentOS desktop works. For now, let's close this window. VirtualBox allows us to do things that wouldn't be possible with a physical computer, such as snapshots. We can snapshot our VM so that we never have to install again. If anything goes wrong and we want to revert to a fresh installation, we can. To snapshot our new VM, press the Host key plus T. Let's call this first snapshot Fresh Install. and click on OK. To shut down your CentOS VM properly, select the top right menu in the title bar and click the power button. This will let you restart or shut down your VM, but we're not going to do it quite yet. Click on Cancel. If you want to revert back to the previous snapshot, go out of full screen mode by pressing Host plus F. And then click on the Close gadget to close the VM window. You will be presented with three options: save the machine state, send a shutdown signal, or power off the machine. Selecting Send a Shutdown Signal is the nice way to shut down an OS, and is basically doing the same thing as selecting the shutdown option from within CentOS. Selecting Power Off just pulls the virtual power cord. Linux is pretty good at handling this sort of thing, but there still may be disk corruption, so I don't recommend it. However, if we want to revert to the previous snapshot, we're not concerned about the current state of the disk since it's snapshotted. Select Power Off the machine and then click on Restore Current Snapshot, Fresh Install, and click on OK. Your VM will now be reverted back to the previous snapshot, which currently is the fresh install. In order to configure and test Linux iSCSI storage area networks using VirtualBox, we need more than one virtual machine. We'll need two VMs, and we want to have both VMs to be able to access each other's network interfaces. We may also want to have the VirtualBox host or other computers on the physical network to have network connectivity with the VM guests. In order to do this, we'll need to configure the VM network interfaces. In order to clone your VM, you need to make sure that it is shut down. If your VM is running, shut it down now using the VirtualBox Manager. Once it's shut down, you can continue. To configure the network settings, click on VM, and then click on Settings, and then Network. Change Attached to NAT to Attached to Bridged Adapter. In the Names section, make sure you select the physical network adapter of your host machine that has access to the internet. In my case, the host is running on Linux and I'm using the wired network adapter, so I'm going to choose ENP0S25, which is the name that my Linux host installation has chosen for it. If you're using Mac OS or Windows, choose the appropriate network interface that your host is using. Once that's done, click on OK. We also need to discard the save state so our VMs boot up fresh for the first time. If you don't do this, then all of your VMs will boot up and assume the same IP address because that is a live setting in RAM which is included in the save state. Make sure your VM is selected and then click on Discard. Click on Discard again. Once we have our VM network adapter configured, we want to clone the VM. In the VirtualBox Manager window, go to the Machine menu and select Clone, and a dialog box asking for the VM name should appear. Let's call it RHOST1. Also click the box to reinitialize the MAC addresses of all network cards. This is so all network cards have unique MAC addresses, so even though the rest of the VM is identical, the MAC addresses won't be. Now we have to choose the type of clone we want. A full clone makes a completely independent VM that can be moved without the original, but also takes up an equal amount of disk space as the original. If you foresee moving one VM without the other, you may want to choose full clone here. However, for our purposes, making a linked clone is perfectly fine and uses less disk space. I'm going to choose linked clone. Now click on Clone. Now let's click on the original VM again and create a second linked clone. Select Machine, and then Clone. Let's name this one RHOST2. Click on Linked Clone, and reinitialize the MAC addresses of all network cards, and then click on Clone. Now we should have two virtual machines named RHOST1 and RHOST2. The name service switch, or NS switch file, is used by applications to determine sources to get name service information from. This isn't just for domain name resolution order, but rather for multiple categories. Each category of information is identified by a database name. The first column of the file is the database name. The remaining columns specify the order in which to look up the data. The following databases are understood: aliases for mail aliases, ethers for Ethernet numbers, group for groups of users, hosts for host names and numbers, init group for supplementary group lists, net group for network groups, networks for network names and numbers, password for passwords, protocols for network protocols, public key for secret keys used by NFS and NIS+, RPC for remote procedure call numbers, services for network services, and lastly, shadow for shadow passwords. For this course, we're mainly interested in the host keyword. Possible options would be files, DNS, NIS, NIS+. The latter two would use Sun's NIS or NIS Plus for hostname resolution. The first two would be for more common situations. The Files option specifies to resolve hostnames using the local name resolution file, etc hosts. DNS would instruct the client to resolve via DNS. We can use both and it will try them in order left to right. For instance, it's common to use host:/file/DNS. This way it will consult the etc host file first and then try to resolve with DNS second. This allows us to override DNS with a local etc host entry. After each option, we can have an optional status and an action inside square brackets. The status can be one of success where no error occurred, not found where the lookup succeeded but the entry was not found, unavail where the service is permanently unavailable, or try again where the service is temporarily unavailable. This could mean that the file is locked or the server can't process this many requests. It's temporary. The action can be one of return, which returns the result right away, continue, which moves on to the next method in the list, or merge, which allows the system to move on to the next method after finding a result and then merges the results. We can use an exclamation mark to negate the status to match anything but what is in the square brackets. In our example earlier, it would return if DNS was not unavailable, which is the same thing as being available, and then not move on to resolving via the etc host file. There are two client-side name resolution files that we should be concerned with in Enterprise Linux 7, resolve.conf and nsswitch.conf. The purpose of resolve.conf is to provide a list of global DNS servers for our client to query when resolving DNS names. The format of the file is fairly simple. There are two columns. The first column will have either search, domain, name server, sort list, or option in it. If it is search, it will be followed by up to 6 domain names with a total of 256 characters. That will be appended if you try to resolve something incomplete. For instance, if you tried resolving the word test, and the search line included localnet.com, ford.com, and apple.com, it would try to resolve test.localnet.com, test.ford.com, test.apple.com, and lastly, test by itself. One of these domains has to be a local domain name. If you do not include a search line, then it defaults to your local domain name. For instance, if my local domain name was localnet.com, and I tried resolving test, my system would resolve test.localnet.com first, and then try to resolve test second, even if I did not have a search line. If the first column specifies domain, it will append that domain to the end of a short name. Normally this is our local domain name, but if we wanted to change it, we could. For instance, if we had domain space otherdomain.com, and we resolved test, it would try to resolve it to test.otherdomain.com. You only need to do this if your local domain is not the same as the rest of your network. The keyword we use the most is nameserver. The nameserver keyword is followed by a DNS server IP address to query. For instance, nameserver space 4.2.2.2. You can have up to 3 nameserver lines and the client will query them in the order they're listed. The sort list keyword allows us to sort IP addresses in certain networks. For instance, if we had sort list space 130.155.160.0 / 255.255.240.0, it would allow addresses returned to be sorted in this network. There can be up to 10 network and subnet pairs. The last keyword in the first column is options. The options keyword lets us set DNS client options, such as querying the name server's round robin to spread the load, a timeout, or the number of attempts the client will query the DNS server before giving up. Keep in mind too that if you want to set DNS name servers per network interface, you can do so by adding them to the interface-specific network configuration files. The /etc/resolve.conf is a global configuration file. Also keep in mind that if you set your DNS servers in the interface-specific configuration file, and you also set the pure DNS directive to yes, then those DNS servers will get copied to /etc/resolve.conf automatically. We have more than one command to query DNS servers, including the legacy nslookup. However, dig does such a good job, I'm going to focus on it. Let's type in dig space redhat.com and look at the results. In a terminal, type dig space redhat.com and hit enter. This shows information on redhat.com. The dig command shows the header, which includes the dig command version number and the global options used by dig. It also shows the question section, which is the question it sent to the DNS server. Since the default question is an address query, it shows that we made an address query. Then comes the answer section, which is the response from the DNS query. In our case, it shows the address record. Next is the authority section, which displays the DNS name server that has the authority to respond to this query. Lastly is the additional section, which displays the IP address of the name server listed in the authority section, followed by stats about the query, including the amount of time it took. If we want to pare this down and only show the answers section, we have to add some options. Type in clear, and then type in dig space redhat.com space plus no comments space plus no question space plus no authority space plus no additional space plus no stats, and hit enter. You can, of course, choose to hide any of these individually if you wish. An interesting shortcut is to turn off all sections and then turn the answer section back on. Type in dig space redhat.com space plus no all space plus answer. This is a shorter line to type, but provides the same output as the long line we typed in previously. By default, dig queries the address record, but we can select a different record if we wish. To do this, filter by the record type. For instance, to ask for the mail exchange record, let's type in clear, and then type in dig space redhat.com space capital MX space plus no all space plus answer, and hit enter. If you want the name server address, just replace the MX with NS for name server. To view all records, replace MX with ANY. We'll bring our line back by pressing the up arrow key, and then replace MX with the word ANY, and hit enter. If you just want the IP addresses, which might be useful in the case of shell scripts, you can use the plus short option. Type in clear, and then type in dig space redhat.com space plus short, and hit enter. This can be combined with any of the record filters we just discussed. A reverse DNS lookup takes the IP address and finds the DNS name associated with it. We will need to use the -X option to do a reverse lookup. We'll use the IP address that we got from the previous query. When I did it, I got 209.132.183.105. So to do a reverse query, we'll do dig space -X space 209.132.183.105 space plus short, and hit enter. This shows us the DNS name associated with this IP address using the short form. Another common task is to query a specific DNS server. In the default output, it shows us the DNS server that responded, which may not be the one we want to query. To specify a DNS server, precede its IP or name with an @ symbol. Type in dig space @ ns1.redhat.com space redhat.com. This will query the ns1.redhat.com DNS server for the address record for redhat.com. Hit enter. This is most useful when querying our own DNS servers to verify that they're giving the answers that we want. You can also do bulk DNS name queries by making a text file with each DNS name in it on a separate line. For instance, let's make a file called dnsnames.txt in our home directory using vi. Type in clear, and then type in vi space dnsnames.txt and hit enter. In this file, we're going to add 3 lines by pressing the I key to go into insert mode, and then we're going to type in redhat.com, enter, forward.com, enter, and centos.com, and we'll hit enter again. Save and exit by pressing escape, X, enter. To use this file, we'll pass the -F option to dig and specify the file name. Because we're getting back answers from multiple sites, we'll probably want to add the plus no all and plus answer options as well. So type in dig space -F space dnsnames.txt space plus no all space plus answer, and hit enter. We can specify the type of record as well, like we did earlier. If you find yourself typing in the same options to dig every single time, you can store them in a file called .digrc in your home directory. In this file, just add the options such as plus no all space plus answer on one line, and they will be automatically appended when using dig unless you override them. To install the client tools, we'll need to log into our RHOST1 VM and open a terminal. We're going to install the bind utils package. It may already be installed, but we'll want to make sure. In a terminal, type in sudo space yum space install space -y space bind -utils and hit enter. Type in your password if prompted. Let's take a look at what's inside the bind utils package. type in clear, and then type in rpm space -ql space bind-utils, hit enter. We can see that we have a few commands, including dig, host, nslookup, and nsupdate. This will be perfect for this chapter. Now let's log into rhost2 and do the same. In a terminal, type in sudo space yum space install space -y space bind-utils and hit enter, and type in your password if prompted. Two tools that are included in the bind-utils package are host and nslookup. Both tools provide name resolution but are quite different. In rhost1, log in and open a terminal. In the terminal, type in host space google.com and hit enter. We can see that it resolves google.com. Host is a simple tool that is useful when you just need to resolve a host name quickly. There are a few options that can be specified, but it's nowhere near as powerful as dig or nslookup. The other tool we can look at is nslookup. nslookup is the legacy name resolution tool that uses its own resolver code as opposed to dig, which uses the operating systems. For years, nslookup came with a warning that said it was going to go away, but with the most recent versions of bind, it seems to have been elevated back to full status. Type in clear, and then type in nslookup space google.com, and hit enter. Some things are easier when using nslookup than when using dig, and it may be more familiar to users of other operating systems. However, I find myself using host for simple resolution tasks and dig for more complex ones. nslookup gets lost in the middle somewhere. If you want to know more about nslookup, type in man space nslookup and hit enter. For this exercise, we'll need to be logged into our rhost1 VM and have a terminal open. We'll install both the bind server package and the bind utilities package if we don't have them already. Type in sudo space yum space install space -y space bind-utils and hit enter. Type in your password if prompted. Once those are installed, let's take a look. Type in clear and then type in yum space list space installed space pipe space grep space caret bind and hit enter. And this shows the bind package and some of its dependencies. Now let's enable and start the service. Type in clear again and type in sudo space systemctl space enable space named and hit enter. And then start the service by bringing a line back and changing enable to start. And hit enter again. I won't spend too much time on how DNS name resolution works, as that is a topic I will assume you know. However, just to make sure terminology we cover later makes sense, I'll skim it. DNS namespace is a hierarchy. At the top is dot, which is the root of the tree. The levels right below it are the top-level domains, or TLDs. Examples would be com, net, or org. Below the TLD is the domain, which is a collection of hosts. An example of a domain would be redhat.com. Below the domain will be subdomains, such as access.redhat.com. These domains can then be subdivided further depending on the needs of the organization. Deep within the organization would be the hosts, which have host names. For instance, if we had a server called rhost1 in the access.redhat.com subdomain, its fully qualified domain name, or FQDN, would be rhost1.access.redhat.com. What is more important for us is that sections of a company's DNS tree can be divided up and given to one DNS server or another to manage. These sections don't have to correlate exactly to subdomains and domains either. One DNS server could manage different portions depending on how the network is configured. For instance, DNS Server 1 could manage the host in access.redhat.com, and DNS Server 2 could manage resolving the host directly under redhat.com. DNS names inside of an organization can be managed by the DNS administrators themselves. But if that host is to be accessed from the internet by its DNS name, it needs to be registered with a domain registrar. This lets the rest of the world know who manages the resolution for that particular name. Not anyone can be a registrar, as they are licensed by ICANN, or Internet Corporation for Assigned Names and Numbers. I mentioned that at the top of the tree are the root servers designated by the dot. There are not many of these servers running, but they do have mirrors to share the load. We can see where they are by looking at a file included in the bind package. The file is /var/named/named.ca. This lists both their IP version 4 addresses as well as IP version 6 addresses. It's important to note that the root servers only handle queries for the top-level domains. If you try to resolve access.redhat.com, the root server will tell you which DNS server to follow up with that manages that domain. The rest of the resolution process goes through other DNS servers. If the root servers handled all DNS queries, they'd be overloaded in the first second of operation. In DNS, there are several roles for hosts which interact with it. These include primary DNS server, secondary DNS server, caching only DNS server, forwarding DNS server, and lastly, DNS client. We'll quickly go over them now. A primary DNS server or master server has control over its domains and/or subdomains. Each domain has to have a primary DNS server. It may also have other types of servers as well, which we'll talk about in a moment. On the primary DNS server is a collection of zone files. A zone file describes the domains and/or subdomains that the primary DNS server manages. Changes to these zone files will only be done on the primary DNS server. A secondary DNS server or slave server also has authority over its domains and holds copies of the zone files. These are copied over from the primary DNS server. Any changes to the zone files are done on the primary DNS server, and the changes propagate automatically. A third type of DNS server is a caching-only server. A caching-only server does not hold any zone files and has no authority over its domains. It only caches the results of queries by clients. Its job is to relieve the primary and secondary servers from having to answer queries. A fourth type of DNS server is a forwarding DNS server. Its only job is to forward queries onto other DNS servers. Those servers could be primary, secondary, or caching-only servers. The last role in DNS is the client, which queries the DNS servers to resolve DNS names to IP addresses. The main bind configuration file is at /etc/named.conf. Let's open this file and less. Type in sudo space less space /etc/named.conf and hit enter. This file includes global options plus zone and include statements. The zone statements declare a zone, and the include statements include external files. All statements start with a left curly bracket and end with a right curly bracket and a semicolon. Statements can be nested this way, but always follow the same pattern. Single-line comments start with double slashes. If you want a multi-line comment, you can include it between a /* and an */. We can see an example of this by scrolling down a bit. Now let's scroll to the end of the file. The zone statements declare a zone and then point to the zone file that resides in the /var/named directory. There's nothing in the zone statement that tells you this, you just need to know it. Take a note of the name of the file in the zone statement. After the file keyword, it says named.ca. We'll look at this file later in the course. Press Q to quit. For this exercise, you'll want to be logged into your RHOST1 VM and have a terminal open. Since we already installed the bind and bind utils packages, we won't need to do that now. They do need to be installed in order to proceed though. To configure a caching-only DNS server, you'll need to edit the named.conf file. Let's load it into VI by typing in sudo space vi space /etc/named.conf and hit enter. Enter your password if prompted. Now go into insert mode by pressing I. We want to change the listen on port from localhost to any. If you want to also answer IP version 6 requests, change the following line from localhost to any as well. In addition, change the allow query line to any. Now scroll down past the comment and change both DNSSEC lines to no. And save and exit by pressing escape:*X and hitting enter. Let's check the DNS configuration file using named-checkconf. Type in sudo space named-checkconf and hit enter. If you don't get any errors, then start the named service. Type in sudo space systemctl restart space named and hit enter. Let's also check the status of named. Bring your line back and change restart to status. If you get error messages, then double check the previous steps and try restarting the named service again. If all is well, then enable the named service to start on boot. Bring your line back and change status to enable and hit enter. Now let's add the DNS service to the firewall. Type in clear and then type in sudo space firewall cmd space -- permanent space -- add service space DNS and hit enter. And then reload the firewall rules by typing in sudo space firewall cmd space -- reload. Next, switch over to your RHOST2 VM and open a terminal. To finish our configuration, we'll change the resolve.conf file to include our new name server. Type in sudo space vi space /etc/resolve.conf and hit enter. Type in your password if prompted. Go into insert mode by pressing the I key, and then delete the two name server lines. Once that's done, we'll add our own. Type in name server, space, and enter the IP address of your RHOst1 VM. In my case, it's 192.168.1.88. Make sure you enter your RHOst1 IP address here. Now save and exit by pressing escape:*X and hitting enter. Let's test our DNS configuration using dig. We'll force dig to use our caching-only DNS server to resolve the request. Type in dig space @ followed by the IP address of RHOst1 space google.com. This will force dig to use the DNS server of RHOst1. If this works, then our DNS server is resolving. You can also try to resolve without the DNS server IP address to ensure that the etcresolve.conf file is correct. To do this, bring your line back and remove the @ and RHOst1's IP address. Type in clear, and then bring your line back and remove the @ and RHOst1's IP address, and now hit enter. If this works, then our caching-only DNS server is functional and our DNS client is configured. Now that we've looked at the bind configuration, let's take a look at a zone file and analyze it. Type in sudo space less space /var/named/named.localhost into a terminal. A zone file contains directives and resource records. The directives control how the DNS server operates and how to apply settings to the zone. The resource records apply an identity to the domain. To differentiate between directives and resource records, you should know that directives start with a $. We can see in this file that we have $TTL as an example directive followed by its option. For resource records, we have an NS or name server record, an A record for an IP version 4 address, and a quadruple A record for an IP version 6 address. The name of this file is named.localhost, so that name is resolved to 127.0.0.1 if we're using IP version 4. We could also have a CNAME record or alias, an MX record for mail exchange, or a PTR record, which is a pointer to a different location in the namespace. PTR records are used for reverse lookups. Lastly, we have an SOA record, which is a start of authority. This defines authoritative data for the domain. The SOA record can include the following data: serial, which is the number of times the zone has been updated. Refresh is the amount of time a secondary server will wait before sending a request to update the zone. Retry is the amount of time the secondary server will wait before sending an additional request to update the zone. And lastly, minimum is the amount of time a name server will cache zone data. There are commands included with Apache that we can use to manage it. The Apache CTL command allows us to start, stop, restart, and reload the service. By using a separate command, we can give a non-root user privileges using sudo to administer the web server. HTPassword is used to create passwords for basic auth authentication. HTTPD is actually the server binary, but it can be used to get the Apache version as well as test the configuration file for syntax errors. The Apache configuration files are in /etc/httpd. The main configuration file is stored in /etc/httpd/conf and is named httpd.conf. We used to edit the main configuration file directly, but if we're adding configuration directives such as virtual hosts, it's better to add a new configuration file to /etc/httpd/conf.d. The files in this directory are processed after the main configuration file. Also inside /etc/httpd/conf.d are 3 other configuration files. The autoindex.conf file configures mod_autoindex directory indexing. The userdir.conf file configures access to user directories. For example, http://localnet.com/user1. This is disabled by default. The welcome.conf file configures the welcome page, which is displayed when no content is present. Configuration files that load modules are stored in /etc/httpd/conf.modules.d. There are also links to 3 directories in /etc/httpd. These are /var/log/httpd, where logs are stored, /usr/lib64/httpd/modules, where additional Apache modules are stored, and lastly, /run/httpd, where runtime information is stored. When Apache runs, it processes the files in /usr/lib64/httpd/modules first, and then the configuration options in /etc/httpd/conf/httpd.conf, and lastly /etc/httpd/conf.d. I won't spend too much time talking about how web servers work, as I assume you already have this knowledge. I will skim over a few items briefly though. HTTP, or Hypertext Transfer Protocol, is a protocol for the web which provides the standards for display and hyperlink content in the Internet. A web server provides non-sequential access to content, usually in HTML format, to clients usually via the HTTP protocol. The secure version of HTTP is HTTPS, which uses SSL and TLS to encrypt the tunnel. There are many different types of web servers, but Apache has nearly 50% market share of all active websites. The popularity of the web and open source itself tracks the popularity of Apache directly. Early on, Apache was the killer application for open source in the web, as it could host more than one website per server via its virtual host ability. Another popular open source web server is Nginx, which has been gaining on Apache over the years due to its speed. Roughly 20% of active websites run on Nginx, so it's worth the trouble learning. Google has its own custom web server as well, which provides roughly 8% of active websites. Other web servers would include Microsoft's IIS, which leads the market in parked domain names. This means people have reserved the domain but aren't using it. Microsoft owns a number of web hosting, cloud hosting, and domain registration companies, which contributes to this number. About 7% of active websites run on Microsoft IIS, although at one time it was as high as 38%. Web clients in order of popularity would be Google Chrome, Apple Safari, UC Browser, which is used in China, Microsoft Firefox, followed by Microsoft's Internet Explorer and Edge browsers. I mentioned in a previous video that Apache has some directives for restricting access based on user, group, network, or host. Let's take a closer look. With require user, access is granted to a specific user based on their username or user ID. We can deny the same way with not require user. Let's see what this looks like. To allow user access by user, we just specify their name. To deny by user, we change it to not require user and again specify their name. We can allow or deny by group as well by using require group and not require group. For both, we can just specify the group name. With require valid users, access is granted only to valid users. For more broad control, we can allow or deny based on network addresses by using require IP and not require IP directives. To use this, we specify the network address without the host portion. If you want to allow or deny based on host name, use the require host or not require host directives. We can specify a host or even a portion of a domain name to allow or deny. Apache will do a reverse DNS lookup on the IP address attempting to access the resource, and then a forward lookup to make sure the records match. Only if both are consistent will the host be allowed. To grant all access, use require all granted. To deny all access, use require all denied. To allow access to hosts on the local network, use require local. When multiple required directives are used, only one has to be evaluated as true to allow access. For instance, if we had a require user user1 and require group admin, then user1 would be allowed even if they were not in the admin group. If we wanted to require all conditions to be true, we can group our access control into a require all container. The default acts like a require any container. There is also a require none container. Lastly, we can specify conditions and check environmental variables as well. We can do this with an if container or the require env directive. Like any service that's outward facing, Apache has a large attack surface. It's a very well written piece of software and is secure, but also benefits by being protected by SE Linux. A lot of functionality is denied in the base configuration. If you want Apache to do anything outside the norm, you will need to change an SE Linux boolean or two. On rhost1 in a terminal, let's get a list of SE Linux booleans for Apache by using get sebool. Type in get sebool -a pipe grep httpd and hit enter. And go ahead and scroll up to the top of the list. A few booleans that are important are httpd_anon_write, which allows Apache to write to any directory with the type of public_content_rw_t. This could be an existing directory, or you can change the security context of a directory manually, and with this boolean set, access it with Apache. By setting httpd_can_check_spam, you can have Apache check for spam. To get Apache to act as a network relay, set httpd_can_network_relay. If you want Apache to send mail, set httpd_can_sendmail. To use CGI scripts, set httpd_enable_CGI. This should be the default. You can get Apache to act as an FTP server by setting httpd_enable_ftp_server. By default, Apache can't read files in a user's home directory. If you want this functionality, set httpd_enable_homedirs. If you want Apache to use a Windows share, NFS share, or a fused file system, you may need to set httpd_use_cifs, httpd_use_nfs, or httpd_use_fusefs booleans. Lastly, if you want Apache to query NS records, set httpd_verify_DNS. This is not all booleans associated with Apache. There is a man page for the httpd SELinux booleans named httpd_SELinux. However, it is not installable as a package. We have to create it. First, let's install the SELinux policy devel package by typing in clear and then typing in sudo space yum space install space -y space SELinux policy devel and hit enter. Type in your password if prompted. Once that's installed, we can create the man page using the se policy command. Type in clear and then type in sudo space se policy space man page space -a space -p space /usr/local /man/man8.mandb and hit enter. If this completed successfully, type in clear and then read the man page by typing in man space httpd_SELinux and hit enter. This will not only tell you about the SELinux booleans for Apache, but also the different file contexts. We need to install the Apache web server now. You will want to be logged into RHOST1 with the terminal open. To install the server package and the tools, type in sudo space yum space install space -y space httpd and hit enter. This will also install the httpd-tools package, which we want. Now let's start the service and enable it so it starts at boot. Type in clear, and then type in sudo space systemctl space start space httpd and hit enter. Now ensure it starts at boot by bringing your line back and changing start to enable and hit enter again. Now we need to open a port in the firewall. Type in clear, and then type in sudo space firewall-cmd space --permanent space --add-service space http and hit enter. Now reload the firewall rules by typing in sudo space firewall-cmd space --reload. Now we should be able to view the default web page. Open up Firefox and browse to localhost. We see the welcome message. To make this go away, we'll need to edit the welcome.conf file. Go back to your terminal and type in clear, then type in sudo space vi space /etc/httpd/conf.d/welcome.conf and hit enter. Now comment out all lines by prepending them with a hash. Go into insert mode by pressing I, and then comment out all lines by prepending them with a hash. And save and exit by pressing escape:*x and hitting enter. Now we need to reload the config or restart the service. We can do this with a systemctl command like we would with any other service, or we can use the Apache CTL command. Type in sudo space Apache CTL space graceful and hit enter. This reloads the configuration without a full restart of the service. Now go back to your Firefox web browser and reload the page. You should now see an index of files, which should be empty since we don't yet have any. You'll also want to install the Apache documentation. To do so, go back to your terminal and type in sudo space yum space install space -y space httpd-manual and hit enter. Now let's get a list of files in the httpd-manual package. Type in clear and then type in rpm -ql httpd-manual and hit enter. This documentation is more useful than man pages for this particular server. The HTML documentation in this package is basically the Apache website documentation. To view the local copy from this package, use Firefox. Type in clear and then type in Firefox /usr/share/httpd/manual/index.html and hit enter. You can also type this URL into the address bar if you already have Firefox running. Another tool that may be useful for browsing our own websites for troubleshooting purposes is elinks. To install it, go back to your terminal and then type in sudo yum install -y elinks and hit enter. Elinks is a command line web browser, so we can use it from the terminal. For example, type in elinks google.com and hit enter. It may have problems viewing more complex websites, but can be useful for simple stuff. The main Apache configuration file is stored in /etc/httpd/conf/httpd.conf. Let's take a closer look at the layout. The Apache configuration file has a long list of possible directives. Directives are key value pairs. Comments start with a hash symbol. Global directives are alone on the line, but directives can be inside a container. A container begins with the container name within angle brackets. The container holds various directives and then closes similar to how HTML or XML works. We won't cover all directives in this video as there's over 650 of them, but I will highlight some more common ones. Listen specifies the IP address and ports to listen to. Server root is the base directory for the server installation. Server admin is the email address that the server includes in messages sent to the client. Server name is the host name and port that the server uses to identify itself. User is the user that the Apache server runs as. Group is the group that the Apache server runs as. Add handler maps the file name extension to a specific handler, such as the PHP processor for PHP files. Alias maps URLs to file system locations. Directory index sets the file to look for when the client hasn't specified. For instance, if a client loads localnet.com, the directory index directive will give it localnet.com/index.html if that's how it's configured. Document root is the directory where the website files are stored. Log format describes the format of the log. Log level sets how much logging is done. Custom log sets the file name and format of the log. We can either define a custom log and set the format with a custom log directive, or we can just specify the file and use the log format directive to define the format. Error log is the location where the server logs errors. Error log format specifies the format of the error log. Options configures which features are available in a directory directive and has multiple possible values. The exec CGI option allows execution of CGI scripts. Follow symlinks will follow symbolic links in the file system. The includes option allows server-side includes. The includes no exec option will allow server-side includes, but not allow the exec command. The indexes option, when turned on, will return a list of files in a directory if there is no index file to view. Multi-views fakes file extensions based on media type. All turns on all options except for multi-views. Multi-views has to be specified individually. None does just that, turns all options off. The allow override directive specifies which type of directives are allowed to override globals. These directives would be placed in a .htaccess file. The allow override directive is only allowed in directory sections. When allow override and allow override list are set to none, then the .htaccess files are ignored. Allow override list is a lot like allow override, but specifies individual directives that are allowed to override globals. For access control, we can use require, which allows or denies access by user, group, host, network, or domain. If you'd like to look up all Apache 2.4 directives, visit the Apache website. My primary motivation for covering Apache is that it's on the R8CE test. My secondary motivation for covering it is its market share. Odds are you will be running into Apache in the industry, so it's important to know. Even if you don't use Apache, people may reference it as a benchmark on how to create web servers. Apache is still a good web server and has many wonderful features, even if some servers like Nginx have passed it in some areas. Apache's killer feature during the beginning of the web era was that it supported virtual hosts. This meant that it could host more than one website per physical machine. As silly as it sounds now, web servers used to host one website per physical machine until Apache changed that. Apache has access control at the user, host, and group levels. This provides a lot of control over who gets to access the website. Apache supports dynamically loaded modules. This allows it to be expanded with new functionality or slimmed down if extra functionality isn't needed. Apache integrates common configuration options into the source code, making administration easier. It also supports multiple authentication methods, including passwords and digital certificates. It has support for compression to speed up data transfer. Apache has intrusion detection and prevention support, as well as secure web connections using SSL and TLS. Apache supports individual dispersed per-service configuration files. And lastly, support for reverse proxies and proxy load balancing. In this exercise, we will create a private site that requires logging in and entering a password. For more details on Apache access control, please refer to the previous chapter of this course. For this exercise, you should be logged into RHOST1 and have a terminal open. Also, make sure that you've completed the previous videos that installed Apache, configured the firewall, started the relevant services, and modified the welcome.conf file. Before continuing with this exercise, you should be able to type into a terminal Firefox space rhost1.localnet.com and hit enter, and it should view the index.html file we created in the last video. If not, then troubleshoot that problem first. Now close Firefox. Viewing the error log will cut your troubleshooting time to a minimum. To view the log, open another terminal tab and enter sudo space tail space -f space /var/log/httpd/error_log and hit enter. Type in your password if prompted. This will follow the error log file while you work and is a good practice. To start this exercise, let's create a new directory for our private website. Go back to your first terminal tab and type in cd space /var/www/html and hit enter. Now type in sudo space mkdir space private and hit enter again. Since we're adding multiple files to this directory, we'll wait until the end to set ownership and permissions. For now, leave them as they are. Now we need to edit the Apache configuration file. Type in sudo space vi space /etc/httpd/conf/httpd.conf and hit enter. Go clear to the bottom and go into insert mode by pressing I. We're going to add a directory director for access control to this file. For this exercise, we'll allow .htaccess overrides for auth config. Enter left angle bracket, directory, space double quote, /var/www/html/private, double quote, right angle bracket. New line, tab. Allow override, space auth config. New line, left angle bracket, /directory, right angle bracket. This will allow us to override the main configuration settings with a .htaccess file. We could put the access control in this directory directive instead of the .htaccess file. The advantage to this would be that it only gets processed once when the service starts. With a .htaccess file, it gets processed every time the directory is accessed. The downfall is that only administrators can edit this Apache config file, whereas the webmaster has access to the .htaccess file in the web document root. Now save and exit by pressing escape:*x! And hitting enter. Now let's test the configuration. Type in clear, and then type in sudo space apachectl space config test and hit enter. If your configuration is okay, then continue. Next, we'll create our .htaccess file. Type in sudo space vi space private /.htaccess and hit enter. Go into insert mode by pressing I and then add auth type space basic, new line, auth name space double quote, enter your credentials, double quote, new line, auth user file space double quote /etc/httpd/conf/.userdb double quote, new line, require space user 1. This sets the auth type to basic auth. It prompts us with a nice message and specifies the auth user file of .userdb. It also requires the user named user1. Save and exit by pressing escape, X, ! And hitting enter. Because we haven't allowed auto generation of indexes in the directory directive, we'll need to add an index.html file. Type in sudo space vi space private / index.html and hit enter. And go into insert mode by pressing I. Type in private space index space file or any text that you would like. Now save this by pressing escape, X! ! And hitting enter. Now that we're done adding files to the private directory, let's change the ownership and permissions of it and its contents. Type in clear, then type in sudo space chown space -R space Apache, Apache space private, and hit enter. And let's change the permissions as well. Type in sudo space chmod space -R space 770 space private and hit enter. In order for a webmaster to add files to this directory, they need to be part of the Apache group. No other user is allowed to read or write files here. Since the Apache server runs as the Apache user, it has access. Since we're adding files within /var/www/html, our SE Linux security context has been inherited, so we haven't had to set it. However, if this directory were anywhere else, we'd have to create a new rule for the policy database and then restore the file system. Not doing this could restrict Apache from accessing the files. Now let's create the auth user file that we specified in our .htaccess file using the htpassword command. Now that we're done in the web document root, let's change directories first. Type in cd space /etc/httpd/conf and hit enter. Now type in sudo space httpasswd space -c for create space .userdb space user1 and hit enter. Now enter a password for user1. This does not have to be the same password as user1's login password because they're not logging into the OS, only accessing web content. Now let's change ownership and permissions so nobody but the Apache user and members of the Apache group can access it. Type in clear, then type in sudo space chown space Apache, Apache space .userdb and hit enter. Now let's set more restrictive permissions. Type in sudo space chmod space 660 space .userdb and hit enter. Lastly, let's restart Apache and check the access control with Firefox. Type in sudo space systemctl space reload space httpd and hit enter. This will reload the configuration files and do a graceful restart. Now let's see if it works using Firefox. Type in Firefox space --private-window space rhost1.localnet.com/private and hit enter. By specifying the --private-window option, it won't remember basic auth information, making it easier to troubleshoot. If you're prompted for a password and allowed to view the web page, you have a functioning basic auth website. If it doesn't work, then start troubleshooting by viewing your error log on the other terminal tab. For this exercise, we'll create a directory for group modified content. You will want to be logged into rhost1 with the terminal open. Pause this video as necessary. Viewing the error log will cut your troubleshooting time to a minimum. To view the log, open another terminal tab and type in sudo space tail space -f space /var/log/httpd/error_log and hit enter. Type in your password if prompted. This will follow the error log while you work through this exercise. To start the exercise, let's create a new directory for our private website. Go back to your first terminal tab. Let's change into the HTML directory so we have less to type. Type in cd space /var/www/html and hit enter. Now create the directory. Type in sudo space mkdir space private group and hit enter. Type in your password if prompted. Since we're adding multiple files to this directory, we'll wait until the end to set the ownership and permissions. For now, leave them as they are. Now we need to edit the Apache configuration file. Type in sudo space vi space /etc/httpd/conf/httpd.conf and hit enter. Go clear to the bottom of the file. We're going to add a directory directive for access control to this file. For this exercise, we'll allow .htaccess overrides for auth config. Go to your directory directive for the private directory. Place your cursor on the first line and press Y2 and then move your cursor down below it. Now press P. Lastly, change private to private group. Go into insert mode by pressing the I key and add group. Now save by pressing escape, X, exclamation mark, and hitting enter. Now let's test the configuration. Type in sudo space apache ctl space config test. If your configuration is okay, then continue. We'll now create our .htaccess file. Type in clear and then type in sudo space vi space private group /.htaccess and hit enter. Now go into insert mode by pressing I, and then add on the first line auth type space basic. Hit enter. On the second line type in auth name space double quote, enter your credentials. Double quote, and hit enter. On the third line, type in auth group file, space, double quote, /etc/httpd/conf/.groupdb, double quote. On the fourth line, add auth user file, space, double quote, /etc/httpd/conf/.grouppassdb, double quote, and hit enter. On the fourth line, type in require space group space web group. This sets the auth type to basic auth. It prompts us with a nice message and specifies the auth user file of .grouppassdb. It specifies the auth group file as .groupdb, which includes a list of users in the group. Lastly, it specifies which group the users are required to be in to access the content. Save by pressing escape, X, exclamation mark, and hitting enter. Because we haven't allowed auto generation of indexes in the directory directive, we'll need to add an index.html file. Type in sudo space vi space private group /index.html and hit enter. Go into insert mode by pressing the I key and then type in private group index file and save and exit by pressing escape, X, exclamation mark, and hitting enter. Now that we're done adding files to the private group directory, let's change the ownership and permissions of all files. Type in clear and then type in sudo space chown space -R space apache Apache space private group and hit enter. And we'll change the permissions too. Type in sudo space chmod space -R space 770 space private group. In order for a webmaster to add files to this directory, they'll need to be part of the Apache group. No other user is allowed to read or write files here. Since the Apache server runs as the Apache user, it has access. Since we are adding files within the /var/www/html directory, our SE Linux security context has been inherited, so we haven't had to set it. However, if this directory was anywhere else, we'd have to create a new rule for the policy database and then restore the file system. Not doing this could restrict Apache from accessing the files. Now let's create the auth group file that we specified in the Apache config. Let's cd2 /etc/httpd/conf. And now create the .groupdb file. Type in sudo space vi space .groupdb and hit enter. Go into insert mode by pressing the I key. In this file, add our two users. Note that these don't have to be Linux login users. This is just for Apache's authentication. Type in webgroup space user1 space user2. Now save and exit by pressing escape, X, exclamation mark, and hit enter. Now let's create passwords for our users. This will create the auth user file that we specified in the Apache config. You only need to specify the -C option once as it creates the file. Type in clear, and then type in sudo space httpasswd space -C to create space .grouppassdb space user1 and hit enter. Give user1 a password. And then bring your line back, change user1 to user2, and get rid of the -C, and hit enter. Now give user2 a password. Now change the ownership and permission so only the Apache user can read and write these files. First, we'll change the ownership to Apache. Type in clear, and type in sudo space chown space apache Apache space .group *, and hit enter. Now let's set more restrictive permissions. Type in sudo space chmod space 660 space .group * and hit enter. Now that our permissions are set, let's restart the Apache service and check the access control with Firefox. Type in sudo space systemctl space reload space httpd. This will reload the configuration files and do a graceful restart. Now let's see if it works using Firefox. Type in clear and then type in Firefox space dash dash private window space rhost1 .localnet.com/private group and hit enter. By specifying the dash dash private window option, it won't remember basic auth information, making it easier to troubleshoot. Log in as user1 and enter user1's password. If that works, you're partway there. Now close Firefox, bring your line back, and hit enter again. This time log in as user2. If that works, then you have a working basic auth site that allows groups. In order to configure a basic web server, you need to already have done the following. Apache needs to be installed. You need to comment out all lines in the welcome.conf file and restart the Apache service so the new configuration is loaded. And lastly, the DNS name rhost1.localnet.com needs to resolve to your rhost1 VM's IP address. These things were covered in the installation video in the previous chapter. Once you've done these things, log into your rhost1 VM and open a terminal. We'll start by checking the Apache configuration file for the web document root. Type in grep space caret document root with a capital D and a capital R space /etc/httpd/conf/httpd.conf and hit enter. This shows that the web document root is /var/www/html. Also, let's check the allowed directory index files. Bring your line back and change the search criteria to directory index with a capital D and a capital I, and then hit enter. This shows that our directory index file is index.html. Now let's go to the document root and create that file by name. Type in clear and then type in cd space /var/www/html and hit enter. Now type in sudo space vi space index.html and hit enter. Go into insert mode by pressing the I key and then type in basic space web space server space test space page. Save and exit by pressing escape :x exclamation mark and hitting enter. Now let's view our website with Firefox. Type in Firefox space rhost1.localnet.com and hit enter. If you see the page we just created, then it works fine. If it doesn't work, then troubleshoot the items in the slides at the beginning of the video. This is a very basic web server configuration, but you need to make sure it works before moving on. Before you do this exercise, make sure you have completed the previous exercise, which configured a basic virtual host. In this exercise, we'll create a virtual host that answers on a non-standard port. I've chosen the port 8085 as it isn't being used for anything. Also for this exercise, you will want to be logged into rhost1 with a terminal open. I've created a virtual host file for you and included it in the exercise files for Chapter 6. To copy the file, go to your home directory where we extracted the exercise files zip archive and copy the vhost2.conf file to the Apache conf.d directory. Type in sudo space cp space /exercise files chapter 6 /etc/httpd/conf.d vhost2.conf space /etc/httpd/conf.d and hit enter. Type in your password if prompted. Now let's take a look at it. Type in less space /etc/httpd/conf.d/vhost2.conf and hit enter. Notice that we're specifying *:8085 on the virtual host directive. The rest is almost identical to the previous virtual host outside of the domain name change. Press Q to quit. Before we get too far, we'll want to tell Apache to listen on port 8085. Type in sudo space vi space /etc/conf/httpd.conf and hit enter. Search for listen by pressing your / and type in listen. We're going to add a new line here. Type in listen space 8085, and then save and exit by pressing escape, X, exclamation point, and hitting enter. Let's create our document root now. Type in clear, and then type in sudo space mkdir space /var /www /html /vhost2.com and hit enter. Now let's make an index file. Type in sudo space vi space /var /www /html /vhost2.com /index.html and hit enter. Go into insert mode by pressing I and type in vhost2.com virtual host index file, and then save and exit by pressing escape, X, exclamation mark, and hitting enter. Since we're using a non-standard port, we need to notify SE Linux that it's okay. Type in sudo space SEmanage space port space -at space http underscore port underscore t space -p space tcp space 8085 and hit enter. This will change the type of TCP port 8085 to http underscore port underscore t. Now let's verify. Type in sudo space SEmanage space port space --list space pipe space grep space caret http underscore port underscore t and hit enter. If we see port 8085 in the list, then we're good. Now we need to allow traffic on our new port through the firewall. Type in clear, and then type in sudo space firewall-cmd space --permanent space --add -port space 8085 /tcp and hit enter. And then reload the firewall rules. Type in sudo space firewall-cmd space --reload and hit enter. Now let's test our configuration. Type in sudo space apache-ctl space config test and hit enter. If all is well, then you can proceed. To manage name resolution for this exercise, we'll edit our etc host file. Type in clear and then type in sudo space vi space /etc /hosts and hit enter. Copy the vhost1 line by moving your cursor to it and pressing YY, and then press P twice to make 2 copies. You should now have 3 identical lines. Now edit the second copy and change the domain name to vhost2.localnet.com and the alias to vhost2. Go to insert mode by pressing your I key and just change the 1s to 2s. For the third copy, get rid of the alias and change the domain name to www.vhost2.localnet.com and save and exit by pressing escape, X, exclamation mark, and hitting enter. Before we go further, test the name resolution by pinging vhost2. Press Ctrl-C to cancel it, bring your line back, and change vhost2 to vhost2.localnet.com. And try it again. And then press Ctrl-C, bring your line back, and change it to www.vhost2.localnet.com. And lastly, press Ctrl-C again. If there are no error messages, we'll continue. Now we need to restart the Apache service. Type in clear and then type in sudo space systemctl space reload space httpd and hit enter. To troubleshoot our virtual host, we can follow the log file specific to this host. Open a new terminal tab, and then type in sudo space tail space -f space /var /log /httpd vhost2.com -error_log and hit enter. Type in your password if prompted. Now go back to your first terminal and use Firefox to test the virtual host. Type in Firefox space vhost2.localnet.com :8085 and hit enter. If you can see your index file, then you're good to go. For this exercise, you will want to be logged into RHOST1 and have a terminal open. Virtual hosts let us have more than one website per server. We can have different logs, site name, and access control per virtual host as well. Let's create a basic virtual host now. I've created a virtual host file for you and included it in the exercise files for Chapter 6. To use the exercise files archive, start by downloading it for this course. Extract it into user1's home directory. This should give you a folder in /home/user1/exercise files. As soon as that's done, be sure you are in user1's home directory. To copy the file, go to your home directory where you extracted the exercise files zip archive in Chapter 3 of this course, and then type in sudo cp exercise files /ch06 for Chapter 6 /etc httpd /conf.d vhost1.conf /etc httpd and hit enter. Now let's take a look at this file so we understand it. Type in less /etc httpd conf.d vhost1.conf and hit enter. We start our virtual host container with the name virtual host, followed by the IP address and port to answer on. We've used a wildcard for the IP, so it will answer on all IPs. We've also specified port 80, but we could have chosen something else if we wanted to. We also set the server admin email to webmaster@vhost1.localnet.com. We set the document root to /var/www/html/vhost1.com. With virtual hosts, you can specify a different document root per site. The naming convention is up to you, but I like naming my directories after the website domain name. We also changed our server name for the site to vhost1.localnet.com and added an alias of www.vhost1.localnet.com. This doesn't take care of the name resolution, which we'll fix in a moment. It just means that if someone requests vhost1.localnet.com, that request will be forwarded to this virtual host instead of being handled by the default server. We can also have per site log files, so we've specified an error log and a custom log. When troubleshooting, be sure to follow these logs, not the general ones we've used up until now. Now we need to create our new virtual host document root directory. Press Q to quit, and then type in sudo mkdir /var/www/html/vhost1.com and hit enter. Let's also make an index file. Type in sudo vi/var/www/html/vhost1.com/index.html and hit enter. Go into insert mode by pressing I, and then type in vhost1.com virtual host index file, and save and exit by pressing escape :x and hitting enter. Let's test our configuration now. Type in sudo apache-ctl config test and hit enter. Also, we can dump our virtual hosts. Type in sudo httpd $dump_V hosts and hit enter. Here we see our virtual host. Since we're adding files within the var www.html directory, our SE Linux security context has been inherited, so we haven't had to set it yet. However, if this directory was anywhere else, we'd have to create a new rule for the policy database and then restore the file system. To manage name resolution, you could add a zone file to your DNS server. However, to keep this exercise simple, we'll edit our etc host file. Type in clear and then type in sudo vi/etc/hosts and hit enter. Copy the rhost1 line by moving your cursor to it and pressing YY. Now press P twice. You should have 3 identical lines. Now edit the second identical line and change the domain name to vhost1.localnet.com and the alias to vhost1. Edit the last duplicate line and change the domain name to www.vhost1.localnet.com and delete the alias. Then save and exit by pressing escape :x and hitting enter. Before we go further, test the name resolution by pinging vhost1, which works, then press Ctrl+C. Before going further, test the name resolution by pinging vhost1, vhost1.localnet.com, and www.vhost1.localnet.com. Now we need to reload the Apache config file. Type in sudo systemctl reload httpd and hit enter. And then type in clear. To troubleshoot our virtual host, we can follow the log file specific to this host. Open a new terminal tab and type in sudo space tail space -f space /var /log /httpd vhost1.com-error_log and hit enter. Type in your password if prompted. Now go back to your first terminal tab and use Firefox to test the virtual host. Type in Firefox space vhost1.localnet.com. You should see your virtual host index file. If it doesn't work, then double check your name resolution, and then redo the previous step where we used httpd to show the value of dump vhosts. Also make sure your firewall is allowing web traffic. Lastly, make sure permissions and SE Linux security labels are correct for the document root. Also check the web server logs. Sometimes the answer is right in front of us. Because certificates are the same with SSL or TLS, we can still use the OpenSSL toolkit to create and manage them, even if we're using Mozilla's NSS module for TLS encryption. In a previous video, we installed OpenSSL. The OpenSSL toolkit offers subcommands to create and manage encryption keys, certificate signing requests, digital certificates, and also to test server and client connections. These subcommands are categorized in 3 areas: standard commands, cipher commands, and message digest commands. Let's list the commands in each area. You'll want to be logged into RHOST1 with a terminal open. If we run OpenSSL without a subcommand, it opens in interactive mode. To get out of this mode, press Q to quit. Now type in OpenSSL space list-standard-commands and hit enter. To get a list of cipher commands, bring your line back and change standard to cipher and hit enter. And lastly, to get a list of message digest commands, bring your line back again and change cipher to message-digest. If you find a subcommand that you'd like to get help on, just type in OpenSSL with a subcommand. For instance, if we wanted to know about the gen p key subcommand, we'd type in clear and then type in OpenSSL space gen p key and hit enter. And it gives us a list of options. You can also list supported ciphers and message digest algorithms by using the list-cipher-algorithms and list-message-digest-algorithm subcommands. You can check the OpenSSL man page for more information. Using additional software, Apache is capable of providing secure HTTPS or Hypertext Transfer Protocol secure websites using SSL and TLS protocols. A secure web server presents a digital identity certificate to the client to prove its authenticity and to create an encrypted connection to them. SSL was created in the mid-1990s by Netscape Corporation and released as version 2. Version 2 was quickly replaced in 1996 by version 3 due to some vulnerabilities. TLS replaced SSL and all versions of SSL have been deprecated. TLS is based on SSL version 3, but different enough that they do not interoperate. The current version of TLS is 1.2. Certificates, however, work independently of the encryption protocol. There's 2 parts to how SSL and TLS works. We'll refer to the layers by their current names, TLS Handshake and TLS Record. The TLS Handshake layer manages which cipher will be used, the authentication, and the key exchange. Handshaking is only done once per session. The TLS Record layer gets data from user applications, encrypts it, fragments it to the size determined by the cipher, and sends it to the network transport layer. There are advantages and disadvantages to running an HTTPS website. Using SSL or TLS prevents intruders from tampering with data. With encrypted websites, they can't inject malicious data into the stream. It also prevents intruders from passively listening to data. This keeps passwords and other sensitive data like credit card numbers secure. The disadvantages include longer latency, CPU overhead of the initial asymmetric encryption and later symmetric encryption, and a more complex management environment. The certificates need to be generated through a process and signed by a trusted authority. This process involves creating a public-private key pair and a certificate signing request, or CSR. The CSR contains the applicant's identity, including the company name, host name, and contact information. It also contains a public key. The CSR is encoded and sent to a certificate authority, or CA. The certificate authority signs the certificate after validating the data. The certificate authority is one that's known to web browsers and trusted. Thus, a certificate signed by it is allowed. Another type of certificate that's used only for testing is a self-signed certificate. In this case, the local machine acts as the applicant and the certificate authority, and the data contained in the certificate is not actually relevant. The certificate can create an encrypted tunnel, but web browsers will not consider it secure, and you may have to jump through a few hoops to get the browser to accept it. Self-signed certificates are for testing purposes only, as they don't accurately prove the server's identity. It would be like someone creating their own driver's license to prove who they are. A better alternative, if cost is an issue, is to use Let's Encrypt, a free, automated, and open certificate authority supported by the Electronic Frontier Foundation, Mozilla, Cisco, and others. We only need to install 2 additional packages for setting up secure websites, and they may be installed already, but we'll make sure. You'll want to be logged into RHOST1 with a terminal open. Type in sudo space yum space install space -y space mod _ SSL space OpenSSL and hit enter. Odds are the OpenSSL package is already installed, but it may be updated with this command. The mod _ SSL package is an Apache loadable module that adds support for encrypted websites. It will also add a configuration file to Apache's conf.d directory. Let's take a look. Type in clear and then type in less space /etc/httpd /conf.d/ssl.conf and hit enter. This sets up some Apache configuration directives, including an encrypted virtual host. If we scroll down, we can see that near the middle. Although we can use this as an example, we'll set up our own encrypted virtual host later in the chapter. In this exercise, we'll create a secure virtual host using the key and certificate that we created in the previous video. You will want to be logged into RHOST1 and have a terminal open. Let's start by creating the new document root. Type in sudo space mkdir space /var/www/html/secure and hit enter. Now we need to edit the ssl.conf file. This file contains a virtual host container that we will modify. Type in sudo space vi space /etc/httpd /conf.d/ssl.conf and hit enter. Search for virtual host by pressing / and then typing in virtual host. Change the document root to /var/www/html/secure. Go into insert mode by pressing I and then change the document root to /var/www/html/secure. And change the server name to secure.localnet.com:443. Now press escape and / and search for SSL certificate file. And change the file name from localhost.crt to secure.localnet.com.crt. Now scroll down a bit to the certificate key file line. Change the file name from localhost.key to secure.localnet.com.key. And now save and exit by pressing escape:*x and hitting enter. Now let's dump our virtual hosts. Type in sudo space httpd space -D space $dump _ vhost and hit enter. We should see our previous virtual host as well as a new secure one. Now let's create the index.html file. Type in clear and then type in sudo space vi space /var/www/html/secure/index.html and hit enter. Go into insert mode by pressing the I key and then type in secure virtual host index file and save and exit by pressing escape:*x and hit enter. Now we'll ensure that the correct SE Linux security context is applied. Type in sudo space restorecon space $RV space /var/www/html/secure and hit enter. More than likely this will not be necessary, but doesn't hurt anything to run it. If you create directories outside of var www.html, you'll have to create new rules for SE Linux and then use restorecon. We'll also need to ensure that port 443 is allowed through the firewall. Type in clear and then type in sudo space firewall-cmd space --permanent space --add-service space https and hit enter. And then we'll need to reload the firewall rules. Type in sudo space firewall-cmd space -- reload. Lastly, we'll restart the Apache server. We need to address hostname resolution as well. We'll add a line to the etc host file. Type in clear, and then type in sudo space vi space /etc/hosts, and hit enter. Go down to the line that has rhost1 in it, press YY, and then press P. This will give you 2 copies of it. Now edit the copy and change the domain name to secure.localnet.com. And save and exit by pressing escape:\x! And hitting enter. Now we'll use Firefox to test our new secure virtual host. Type in Firefox space https://secure.localnet.com and hit enter. Because it's a self-signed certificate, we'll need to manually accept it. Once that's done, we should see our index page. Before we can create a secure website, we need to create a self-signed certificate. In the RHCE exam, you will be given a key and certificate, but knowing the process of creating your own can help with understanding SSL and HTTPS. For this exercise, you need to be logged into rhost1 and have a terminal open. You also need to have installed mod_SSL and OpenSSL. Start by changing into the certificates directory by typing in cd space /etc/pki/tls/certs and hit enter. You should be able to do this as a normal user. Now let's generate the RSA private key. Type in sudo space OpenSSL space gen pkey space -algorithm space RSA space -pkey opt space RSA_keygen_bits :2048 space -out space secure.localnet.com.key and hit enter. Type in your password if prompted. This should create a key called secure.localnet.com.key in the current directory. Type in ls to verify. Now that we have our private key, we need to create a certificate signing request, or CSR. Type in clear, and then type in sudo space OpenSSL space req space -new space -key space secure.localnet.com.key space -out space secure.localnet.com.csr and hit enter. This will ask you a few questions. For some options, hitting enter will accept the default option. For country, I'm going to put in US and hit enter. For state, I'll put in CA for California. For locality, I'll put in Los Angeles. For organization name, I'll put in LocalNet. For organizational unit, I'll put in LocalNet. For common name, I'll put in secure.localnet.com. For email address, I'll put in info@secure.localnet.com. And then I'll hit enter for other questions. This will create the CSR in the current directory. Type in ls to verify. We can see our key and our certificate signing request. Now we'll sign the certificate ourselves for testing purposes. Type in clear, and then type in sudo space OpenSSL space x509 space -rec space -days space 120 space -sign key space secure.localnet.com.key space -in space secure.localnet.com.csr space -out space secure.localnet.com.crt and hit enter. This will create the signed certificate named secure.localnet.com.crt. Now list the results using ls. You should see the certificate signing request, and the private key. Now let's change the permissions on the key and move it to the private directory. Type in clear, and then type in sudo space chmod space 600 space secure.localnet.com.key and hit enter. Now let's move it by typing in sudo space mv space secure.localnet.com.key space /private and hit enter. We can check the validity using OpenSSL. First, let's restart the Apache service. Type in sudo space systemctl space restart space httpd and hit enter. To check the validity using OpenSSL, type in sudo space OpenSSL space s_client space -connect space localhost :443 space -state and hit enter. If you get a lot of information on the screen, including details of your certificate, then you're done. Once again, you will most likely not have to do this in the exam, as they will provide you with a key and certificate. However, it's good to know how it all works, and it allows you to practice with secure Apache websites. For this exercise, you'll want to be logged into RHOST1 with a terminal open. We will run a script under CGI that displays some information about the web server. I've created a CGI script for you and included it in the exercise files for Chapter 8. To copy the file, go to your home directory where you extracted the exercise files zip archive in Chapter 3 of this course, and then type in sudo space cp space exercise files /chapter 08 /var /www /cgi-bin /loggedin.sh space /var /www /cgi-bin and hit enter. Now let's take a look at it. Type in less space /var /www /cgi-bin /loggedin.sh. It's a very simple script that presents some HTML on the screen and runs the date command. It also runs the who command. Now let's see it work. Press Q to quit. Let's make it executable by typing in sudo space chmod space +x space /var /www /cgi-bin /loggedin.sh and hit enter. We need to turn on an SE Linux boolean to allow CGI scripts. Type in clear and then type in sudo space set se bool space -P space httpd _ enable _ CGI space 1 and hit enter. Now let's restart Apache. Type in sudo space systemctl space restart space httpd. Now let's test it using Firefox. Type in firefox space rhost1.localnet.com /cgi-bin /loggedin.sh. You will notice that it does not show which users are logged in. Also, an SE Linux alert has popped up. If we click on Show Alert, we can see why. Click on Details, and we can see that SE Linux has prevented the who command from reading the UTMP file. SE Linux keeps a close eye on which commands are accessing which resources. If we wanted to continue, we'd walk through the suggestions to get SE Linux to allow our script to execute. If we wanted to run our CGI script from a non-standard location, we'd want to change our SE Linux security context using semanage fcontext. The security context we want to change it to would be httpd:/sys_script_exec_t. With web servers, we can execute scripts to create HTML content using the CGI or Common Gateway interface. These scripts are often written in C, Python, Ruby, or Perl, but can be written in just about any other language. There are security concerns surrounding CGI scripts, as you don't want a user to execute just any script. The Apache web server uses the script alias directive to determine where CGI scripts can reside. SE Linux also limits whether Apache can run CGI scripts, and script directories need a special security context. Scripts run as the Apache user and can only access resources that the Apache user can access. CGI scripts can be used to gather input from the user, query or update databases, email, or even run system commands, so the possibilities are nearly endless. Nginx is not included in the stock Enterprise Linux software repository, so we'll need to add a new one. In the exercise files, I've included a repo file for Chapter 9. Let's copy it to yum.repos.d. There are two different files depending on if you're using Red Hat Enterprise Linux 7 or CentOS 7. Make sure you copy the right one. If you're using CentOS 7 as I am, then go to your home directory and type sudo space cp space exercise files /chapter09 /etc /yum.repos.d /nginx-centos.repo space /etc /yum.repos.d and hit enter. Type in your password if prompted. If you're using Red Hat Enterprise Linux 7, change the file name to nginx-redhat.repo. Now to install Nginx, type in sudo space yum space install space -y space Nginx and hit enter. There are many reasons why you might want to use Nginx. Nginx is a multifunction tool. With Nginx, you can use the same tool as your load balancer, reverse proxy, content cache, and web server, minimizing the amount of tooling and configuration your organization needs to maintain. Nginx is optimized for speed. We'll talk about that in a moment. Lastly, Nginx has 20% of the active web server market. This puts it in second place behind Apache, which has close to 50%. Nginx is fast because it does not support .htaccess files. All access control is handled in the main configuration file, which is processed once when the service starts. Apache can do this as well. Nginx was designed from the ground up to use an asynchronous, non-blocking, event-driven connection handling algorithm. Nginx spawns worker processes, each of which can handle thousands of connections. The worker processes accomplish this by implementing a fast looping mechanism that continuously checks for and processes events. They've separated the connection handling from the work. Nginx was created to be both a web server and a proxy server. Due to the architecture required for these two roles, it works primarily with uniform resource identifiers, translating to the file system when necessary. Additional modules need to be compiled into the server core and cannot be loaded dynamically. This makes it less flexible than Apache, but more efficient. Nginx doesn't support dynamic content, making it focus on one thing, static content. To serve dynamic content, it has to pass to an external processor for execution and wait for the rendered content to be sent back. This makes it very fast at static content, but not so good at dynamic. There's nothing wrong with running both Nginx and Apache on the same site, with Nginx handling static content and Apache handling dynamic content, such as PHP. When using Apache to host more than one website, we create virtual hosts. The equivalent in Nginx is called a server block. In this exercise, we'll disable Apache, start Nginx, and create a new server block. You'll want to be logged into RHOST1 with the terminal open. We'll begin by stopping the Apache service and disabling it so it won't start on boot. In a terminal, type in sudo space systemctl space stop space httpd. Type in your password if prompted. Then bring your line back and change stop to disable. Now let's start Nginx and enable it. Type in sudo space systemctl space start space Nginx and hit enter. Then bring your line back and change start to enable. To make sure this is working, use Firefox to view localhost. Type in clear and then type in Firefox space localhost. If you see the Nginx welcome page, then you're on the right track. Close Firefox now. Nginx stores its main configuration file in /etc/nginx/nginx.conf. It also has additional configuration files just like Apache at /etc/nginx/conf.d. This is where we'll store our server block configuration. Let's start by creating our new server block document root. Type in sudo space mkdir space -p space /var/www/serverblock/html. I've named it server block so we can keep it separate from the Apache virtual host directories. Now let's create an index.html file in this directory. Type in sudo space vi space /var/www/serverblock/html/index.html and hit enter. Go into insert mode by pressing the I key and then type in Nginx server block index file. Save and exit by pressing escape :x and hitting enter. Now let's cd into /etc/nginx/conf.d. Type in clear and then type in cd space /etc/nginx/conf.d and hit enter. Type in ls. We can see that there's a default.conf file in here. Let's make a copy of the default.conf file and we'll call it serverblock.conf. Type in sudo space cp space default.conf space serverblock.conf. Now let's edit our new server block file. Type in sudo space vi space serverblock.conf and hit enter. There are a lot of similarities with Apache virtual hosts. We see the port number to listen on, the server name, the document root, and the index files. We can also see mappings for error messages. The first thing we'll do is change the server name. Go into insert mode by pressing the I key and then change server_name to serverblock.localnet.com space www.serverblock.localnet.com semicolon. Be sure that you keep the semicolon at the end. It's important. This line will tell Nginx to answer on both serverblock.localnet.com and www.serverblock.localnet.com. Let's also change the root directory for our server block. Go down to the line that says root space, then change the value to /var/www/serverblock/html, which is the directory that we just created. Now save and exit by pressing Escape, X, ! And hitting Enter. Now let's take care of the name resolution. Type in sudo space vi space /etc/hosts and hit Enter. Go down to the RHOST1 line and press YY and then press P twice. This will give you 2 duplicates of the line. For the first duplicate, change the host name to serverblock.localnet.com. Go into Insert Mode by pressing the I key, and then go to the first duplicate and change the host name to serverblock.localnet.com. And then go to the second duplicate and change it to www.serverblock.localnet.com. And then save and exit by pressing Escape, X, ! And hitting Enter. Verify that name resolution works by using ping. We see that it does, so we'll press Ctrl+C to kill it. Now type in clear. The last thing we'll do is restart the Nginx service. Type in sudo space systemctl space restart space Nginx. Now, let's test it using Firefox. Type in Firefox space serverblock.localnet.com. If you see the Nginx index page that we created, then you're in good shape. Anytime you want to host a new website, it's easy to create a new server block. Just create the document root, copy the default.conf file, edit the copy and change the server name and document root, address hostname resolution, and lastly, restart the Nginx service. It really is that easy.
So what's next on your machine learning journey? It's always best to practice as soon as you've learned a new skill. So go to your machine learning tool of choice, grab a data set, and try the algorithms that were new to you. But what if you haven't learned a machine learning platform yet? I'm a big fan of starting with codeless machine learning first. Certainly, if you want to learn R and Python, there are lots of great options in the library. But if you want to give codeless a try, there are 2 learning paths for you. There's a KNIME learning path, and there's an IBM SPSS learning path.